So first we'll start with a discussion of pop quiz that was related to topic motion. So the first question is the graph can be used to represent the motion of an object. Which row in the table gives a quantity plotted on y-axis and the corresponding quantity represented by a gradient of the graph? So it's a well because if you were having a displacement time graph, like if you were having a displacement time graph, what the slope represent the velocity. But if you have a velocity time graph, what the slope represent? The slope represent acceleration. So it must be a velocity time graph in which the slope represent acceleration of an object. In question 2, a tennis ball is moving through air. The diagram shows the horizontal and the vertical components of the velocity. Which of the following gives the magnitude of the velocity in meter per second? So this one is an angle, and with reference to angle, this one is a base for us, and this one is the perpendicular. So we need hypotenuse. So if we need hypotenuse with trigonometric ratios, example, if we use a sine theta is perpendicular divided by hypotenuse. So if we need the hypotenuse, it will be perpendicular divided by sine theta. So what is the perpendicular here? The perpendicular is 5.5. And what about the sine? The angle is there, which is 22.6. So this will be 22.6. So 5.5 divided by sine 22.6, that will match with option C. So we use a trigonometric ratio to work out the hypotenuse, which is a velocity in this case. We can also work out the resultant here by using a Pythagoras theorem, but we don't have an option. Like we can also work out the resultant can be 13.2 square plus 5.5 square in a root. That will also give the resultant velocity because this one is base and perpendicular. So when we square and sum and take a root, we'll get the hypotenuse, which is the velocity. But there's no option which include the Pythagoras theorem. That's why we use a trigonometric ratio to work out the hypotenuse. In question 3, a ball bearing falls vertically from the rest. So if something drops from a rest, what is the starting or initial velocity? 0. And distance is 50 centimeter. You have to convert into meter. So 0.05 meter. Sorry, 0.5 meter, because centimeter to meter we have to convert. And it took 0.32 seconds. Which expression gives the acceleration? So how we can work? We have the distances there. We have initial velocity, which is 0, and we have the time. So we can use the equation of motion in which S equals ut plus half at square, where S is a displacement, which is 0.5. U is the initial velocity, that is 0. The time is 0.32 plus half. Acceleration is due to gravity, which is no expression we need actually, not the equal to gravity. So it should be equals to gravity, but according to we need expression here. And what about the time? It will be 0.32 square. So when we simplify, this will be 0.5. This whole factor will be 0. This will be half 0.32 square times A. When we further simplify, so it will be 0.5 equals 0.32 square divided by 2 times A. If we need A, 2 will be multiplied. So 0.5 multiplied by 2 makes 1 divided by 0.32 and then square. This will give us the acceleration. So 1 divided by 0.32 square, that will give us the acceleration of this object. So that's why A should be the right answer. Is it clear? This was a question 4 of the pop quiz, which was related to motion. A toy car is released from a rest and rolled down a slope as shown. The mass of the car is 0.16 and the speed of the car at the bottom is 2.6. Calculate the increase in the kinetic energy as it accelerates down the slope. So it's a simple increase in kinetic energy or kinetic energy. You can use the formula half mv square. So the kinetic energy EK or KE is equals to half mv square. Whenever you're solving a question, always write the formula as writing a formula is also having marks. And use SI unit. If the mass is in grams, convert into kilogram. So in this case, directly it is in kg, so we don't have to convert. And the speed is 2.6 and then square. So it will be half mv square because we want the increase in kinetic energy. Initially, it starts from rest. So initially it is 0 and the maximum speed it reaches 2.6 when it moves. So the final answer will be 0.54 joules will be there as the SI unit of energy is joules. Then a car accelerates down the slope. The work against the friction is 0.26 or calculate the vertical displacement. So what actually happened as this car, it moves down the slope. So at the top, it is having a gravitational potential energy. So at the top, the car is having GP. But when the car rolls down, it loses some of the energy against the friction. How much energy is lost? It is 0.26 energy is lost. And at the bottom, we worked out when it reached the bottom, it has a kinetic energy. And how much is this kinetic energy? 0.54 joules. So if this is a work done against the friction and original gravitational potential energy, so we will work out the original gravitational potential energy, which will be equals to work done against the friction or energy loss plus the kinetic energy at the bottom. So work done against the friction is 0.26 and the kinetic energy is 0.54. So it will have a GP or gravitational potential energy, which is equals to 0.8 joules. And we need the height or the change in the height. So we have the formula that gravitational potential energy is mgh or change in height. Delta H you can also say. So the energy is 0.8. The energy is 0.8. The mass of the car is given in the question 0.16, acceleration due to gravity 9.81 and height. So if we need the height, the whole factor will go there in division. So when we divide, we'll get 0.51 meter as the height. So this is a height from which this car is being released, and some of the energy is lost to the surrounding in the form of heat. That is the work done against the friction, and the remaining it has a kinetic energy at the bottom. So this was a pop quiz that was related to the motion of an object and the energy.